So this is the third video in the series. We need to actually get him so that he can move left and right. That's obviously an important part of any game. Right now, if you press the keys left and right, or any other keys like A and D for WASD, he doesn't do anything. We're going to add the code in C# in this video. I have another video that I'll be producing for JavaScript. That'll be available on my YouTube channel or on gosub.com. You can find the links and all the information. Starting right from where we left off in the last video, I actually checked out the source code straight from GitHub, and the information on how to download the source is all on on my website on gosub.com. And so right now, as you saw, the guy can jump, but we need to add some stuff to handle keystrokes for left and right movement. I'm going to go ahead and open up mono development. So as you know, we've got these assets down here with scripts, and in the scripts we've got this player behavior, which is attached to our character. Over here, this is where we actually have it selected to be the active script. So here's the script. By double-clicking on this, we open up mono develop, and that's open up over here. And so we're going to add something to detect the keystrokes, and that's going to happen under the update function in here. All right. So we can do a couple different things. The first thing we're going to do is we're going to start with the arrow keys, because right now we have space and we can add arrow. And then it's not hard to add the WASD keys if you want that WASD, that kind of movement with your left hand versus your right hand. So we'll go right into the update function and we'll press return. All right. We're gonna check for a keystroke. So the way to do that is to say if, my computer's a little slow right now, if input dot get key. Now you see there's a get key down and a get key up. We used get key down for space, and that's great because like every time you hit the key, you'd want the jump to be checked. So you press the key, he jumps, you press it again, he jumps again. In this case, when you move left and right, you don't want to have to press the key every time you want to move. That's maybe kind of a roguelike behavior, but in this case, you know, like if you're playing Mario, you're going to want him to move every time, or the whole time you're holding down the key. So the way you check that is you just say get key. And then we need to say what key we want to check. So we're going to look for key code dot left arrow. There we go. So if the left arrow is pressed, then we're going to do something. And go ahead, hit return here, put in my parentheses. So what we want to do is we want to actually move our character some distance to the left or to the right. And the way to do that is to actually say, for example, we need to figure out, well, I'll show you something first. All right, so when you go back up to this function right here, or this part of the function, we're getting the velocity of the character, and we're making him jump a certain distance based on the variable in the character. We're going to do something very similar in this case for the left and right movement. So we'll say get component rigid body 2D, right? Rigid body 2D. And we want to get its velocity again. And we want to set that equal to a new vector 2, because it's going to be a 2D movement, you know, up and down. And we're going to set this equal to move speed and 0 for right now. And this isn't right, and I'll show you why. Now actually the code we did before isn't right either. Before this will actually work, we need to know what move speed is, and move speed shouldn't be too hard to figure out because we already did jump height before. So we can come up here and we can say public int move speed, and we'll get that from the character. So we'll actually be able to click on the icon, the sprite for the character, and we'll be able to change the move speed right in there. Now let me explain what the problem is. The problem is that when we move left or right, we also want to be able to jump, for example. And what we're doing right here, every time we set 0 for the x coordinate, or the x speed right here, and when we set 0 for the y movement right here, we're basically saying that if we're jumping, we're going to stop jumping and we're going to move left or right, which isn't right. So we have to go back, we have to fix the original function too before this will all work. So what we need to do is we need to create a little temporary variable called x, and it's a float. Floats are numbers that have floating point decimals. So there's 1.1, 1.0001, pi, for example, 3.14. So we want to get the x value. So we're going to get that from our component called of type rigid body 2D. And that's going to be its velocity dot x. So whatever the x is, whenever we press jump, we want to keep track of that. So if we're moving to the left or to the right and we press jump, we want to know where we were going. So we want to store that just for a moment. And then we're going to take it and we're going to use it in this call right here. We're going to put the x. So whenever we jump the jump height and we leave our movement whatever it was when we got the jump call. So following that logic, we're going to come down here and we're going to say float y equals get component of type rigid body 2D. And we're going to get the velocity y this time, velocity dot y. So we're going to hold on to that y, and then we're going to say, put it here. So if we're moving through the air up and down, moving up and down, we're going to use that in addition to our moving left and right. So then you get the behavior of like, when you jump with Mario and you can kind of control the way he floats, right? So you jump up in the air and you get the coin, but you also need to make it back to the platform or something. So you jump up, and you kind of press to come back. So hopefully that makes sense. And we're basically going to copy this whole thing. We'll just do this whole section of code because we now need to do it for the right arrow as well. So one thing we need to change is GetKey code dot right arrow, right? Right arrow. So if we're pressing the right arrow, then we want to get that y value, and then we want to set the velocity equal to the move speed y. However, nothing about these two function calls right now is telling us which one goes left and which one goes right. They're actually going the same direction. So if you think about a Cartesian coordinate, the negative x's go to the left and the positive x's go to the right. No matter where you are on the coordinates, if you're adding x, you go to the right. If you're subtracting x, you go to the left. So that tells us that we want to move in the negative move speed. So what this does right here is it just changes the sign of whatever move speed is. So if move speed's 10, this is going to become negative 10. So if we press the left arrow, we would go negative 10. If we press the right arrow over here, we would go positive 10, just regular 10. So hopefully that makes sense now. So we've actually kind of really improved the code here. We've made it so that when we do start jumping, we'll be able to go to the left and the right. While we're jumping, or if we're moving, we won't have to just stop jump straight up, for example. That won't make sense. We won't like that kind of play. And then we got our left and right arrow movement here. So we'll save this, and we'll go back up. You might see that I have a bunch of these. I have a couple different versions of this program running that I work on in between videos. All right, so let's go back to this guy, and we should now, if we click on him, we should have a new move speed down here. So I don't know. Let's give him a 5 move speed. I don't know what'll be good right now, but let's give him a 5. And let's try to check that out. See how this runs. Oh, there he goes. Now, this is going to totally suck because he's going to keep falling off the screen. And it's difficult to see, but we'll do something to kind of make this a little more visible. I'm going to change this number to 2 and press play again. So you can see he moves a little bit left, right, left, right. He can jump and move to the right, jump and move to the left. So that's what we want. We want something like that. So 2 lets us stay on the block right now and kind of move back and forth. In a next video, we'll start building out some terrain and we'll kind of make some sense of where these blocks are. But I just want to be able to control them right now. Because the other thing I want to show you is that when he moves to the left, he's pretty much moonwalking backwards. It's bad enough he's moonwalking, but we probably would want him to change his direction when we make a move. So let's go back to our script. It's already open, but I'll just click on that. What we want to do is we want to keep track of which way he's facing. And the way I would do it right now is I would say, let's keep track of a true-false variable, which we call a Boolean. The short name for that is bool, B-O-O-L. And we want to make sure that when he starts off, we say, okay, we know the character's facing to the right, and if you press the left key, we want him to flip over and just face to the left. And then if we press the right key, we want him to flip again if he's facing left, and so on and so forth. So right here, we'll create a new private bool variable, and I'm going to call this facing right. And you know, a Boolean is true or false, yes or no, on and off. So I'm going to say, is our character facing right? Just to kind of remember that. And we know that initially he is, so I'm going to say facing right equals true, just because the way that the sprite looks. This is private, so we're not going to be able to set that in the sprite itself, or the actor. And this will just set the initial value. Then when we press the left arrow, for example, we're going to change which way he moves, and then we'll just take care of this changing direction thing. And what I'm going to do is I'm actually going to write a little function. I'll start it out down here just so it makes sense. It's going to have no return value, so we'll just say void. I'm going to call it flip. So flip is just going to turn the character left and right based on whichever key we press. We'll go into that later, how that actually happens. So in here we'll say if facing right, so at this point we're pressing the left arrow, right? So pressing the left arrow and we're facing to the right, we need to flip. So if facing right, then flip, right? Simple enough. That's pretty much what we want to do, and we'll just fill in what flip is later. And when we come down here, when we press the right key, you'd think, oh, we don't have to do anything for that, but we do. We have to check to see if he's facing left. So if we don't have a variable facing left, right? Correct? So what we want to say is not facing right. And the way you say not is the bang, or the exclamation point. So if not facing right, then flip. And the code in flip will just handle changing the way the actor faces, no matter which way he's facing. So we'll just flip him over either way. So I'll just put a little comment in here. If not facing to the right, flip to face right. And I'll put a little comment up here. If facing to the right, flip to face left. Okay. So what does flip do? So flip is just a little function that flips the sprite to face the opposite direction on the x-axis. So that's all we're going to do. We're just going to take the sprite and we're going to what we call translate. We're going to translate so he flips over horizontally. So he'll become his mirror image. Now, to do this, we have to get what's called the scaling for the character, for the sprite. And it could be that we resized the sprite when we first loaded it, and we could have skewed it, any one of the 3 directions. There's actually 3 directions: X, Y, and Z. So Z is the one that goes in and out of the screen. So the farther away it is, the higher the z would be, I think, or I'm not quite sure. Maybe it's towards us. So we need to get what's called the scale, and it's a 3D one this time because the x, y, z. So I'm just going to call it the flip scale, and this is it's just going to be a variable that holds it, and we'll assign one of the values for the x coordinate to flip it over, and then we'll set it back to the actor. And in order to, we're going to make a couple calls on this rigid body. So I'm just going to say rigid body 2D. I'm going to declare one. Rigid body 2D. Rigid body 2D. Did I spell that right? Yeah. Rigid body. And I'm going to get that just like we have been. Get component of type rigid body 2D. Make sure it's 2D. So rather than doing like the vector and stuff, I'm actually creating something to hold that right now. So we'll be using rigid body in this case for the rest of the function. And we'll get the flip scale from that. So flip scale equals rigid body. And you see, we can make the call to get component rigid body 2D, but it gets to be kind of cumbersome to have to do that a lot. So rigid body, we're going to get its transform vector, so the local scale for that. And this is the current one, this current scale vectors. So these are what they are when we load it. And then we're going to change just the x, flip scale. And we're going to set the x equal to, well, I'll show you what it's going to be, and I'll show you how to make it simpler. So we're going to set the flip scale equal to the flip scale times -1. So we're just going to set it equal to whatever the opposite was. Kind of like that negative thing we did with the move speed. And you might think, oh, well, okay, let's go back to that. So flip scale equals negative flip scale. Yeah, that's cool too. But here's another way to do it. Times equals -1. So it says multiply it by 1 and assign it to itself. So this is going to flip horizontally along x-axis by just multiplying that by -1. And the interesting thing about this is that, let's say the x scale is 1. It's just whatever size we load it up as. Then we multiply it by -1, which makes it the same size but in the opposite direction. Then we multiply it by -1, which makes it the same size but in the opposite direction again. So we've gone from, say, facing right to facing left to facing right. So you can see how this will work for the move left and the move right, so either way. So flipping from the opposite, whenever we know we're facing the wrong way, we just flip it by multiplying it by -1. And then we want to set this back to the rigid body. So we want to set this transform dot local scale is what it's called, local scale. So we want to set this again equal to our flip scale, right? So we've modified the value. We want to set it back to our rigid body for our physics. And the only thing we need to do now is actually keep track of the fact that now we're not facing the direction we were facing before. So we could say equals not facing right. So whatever facing right was, we're going to set it equal to not whatever it was. Hopefully that makes sense. And so I'm just going to say, put a little note here, we're facing opposite direction now. And if everything went well there, then when we come back, I just press Command S to save it. Come back here, let's check this. And we have that, make sure we have that little, let me just check this again. Make sure that our guy is, yeah, he's got this very small move speed, so he'll stay on top of this block when I move him. Let's play him. Doop, doop. Oh yeah, look at that. So there he is. He's moving left and moving right. And he goes back, whichever way it was. Of course, the sprite we have has some odd shading, but it's okay. We're just learning the details here. All right, so that's pretty much it. I think that's a lot for this video. So we've learned how to do movement with the keys, left and right arrows here. And we've also learned how to flip our sprite to face in the opposite direction. All right, so make sure you subscribe to the YouTube channel.